Welcome to Holley EFI Training Part 25. In this video, we're going to take a look at working with our individual cylinder trims as well as some advanced fuel tuning functionality. Now, taking a look at our individual cylinder trims, we're able to correct for both fuel and spark timing on a cylinder or cylinders that are varying from the other cylinders. So we might have airflow distribution problems, maybe say from an intake manifold design, it's not getting airflow equally into all the cylinders. We can correct for that using these individual cylinder trims. We actually can take things a step further and do that on a three-dimensional table. We can set up all kinds of different things on the axes. I'm going to go through a couple common examples here in this video so you know how to work with individual cylinder trims. So we can do this for both fuel and for spark timing. We're also going to take a look at some other advanced tuning functionality based on our idle control position and our fuel delivery, because there can be some discrepancies based on how much airflow we're inducing from our idle control motor as it's letting more or less air into our engine. So we're gonna have a lot of things to cover in this video, so let's jump in so we can check everything out.
Okay, so let's get started. We're going to be taking a look at working with our advanced fuel and spark tuning concepts and techniques in our Holley EFI software. We're going to find we have the ability to vary our fuel delivery or spark timing outside of what we're finding here in our main fuel table, our main spark timing table, and then our modifier tables. So we understand the concept of these modifiers and the main table and what they represent here in our training course so far. So now we're going to start to introduce looking at cylinder-specific fuel trims, also taking a look at how we can accomplish some advanced tuning and functionality using our specific advanced tuning parameters to be able to offset something like our idle position versus engine RPM. And we'll talk about why we might want to go and have fuel delivery vary based on that a little bit later here in the video. But let's go and first check out our individual cylinder trim tuning here so we can start to work with that and get familiar with that concept, because this main fuel table is just going to be the overall fuel delivered, and it's going to be then splitting that evenly between all the cylinders. But we might find that the engine doesn't have equal airflow to all the cylinders. That can cause some issues with fuel delivery, and we can correct that. So let's jump in here to our system ICF, and let's move down in here under our individual cylinder. Now we're going to find that we have our two sections: fuel correction, timing correction. And right now we can see that we have a cylinder. It's going to list the actual cylinder number here in our firing order, so cylinders 1 through 8. And then we're going to find on our timing here cylinders 1 through 8. Now that's going to depend on the number of cylinders we have available based on the parameters here on the number of cylinders that we've actually specified. So if we specify something like 4 here, we're going to go back into our individual cylinder and notice that it updates that. So when we have 4 cylinders, we could potentially edit. So it will make a difference how many cylinders you have available based on how many cylinders we're listing here. Let's click OK. So jumping back in here, we're going to find that in the fuel correction. Let's start with that first. We're going to find that we have the ability to add or subtract fuel against the cylinder here globally. And what I mean by globally is that at idle, cruising, and wide open throttle, it'll be going in and adding or subtracting fuel based on whatever we place in this singular one-dimensional value. So this may or may not be desirable for your application. We do have some other options here, as we'll find out in a few minutes. So if we take a look here, let's skip back into our fuel tuning window. Let's jump back here just a little bit. And fuel tuning. So we'll find what the injector pulse width is going to be reading. That's going to be what it calculates to open and close the injector to deliver the certain amount of fuel flow that we're expecting. So this is what it splits to all the fuel injectors and all the cylinders evenly. And what we'll find is that we're able to offset that in a specific cylinder here. So if I wanted to go in and add 5% to my cylinder 1, wherever my, jumping into my main fuel table here, wherever my cursor position is going to be at, it'll have a certain amount of fuel flow rate, converting that into the injector pulse width based on all the parameters that we've already talked about: engine displacement, taking a look at the number of cylinders, taking a look at the static flow rate, the lag time, any of the linearization data, and the minimum pulse width. So it's going to be turning that into injector pulse width that we're finding here. The individual cylinder trims, this is going to be looking at specifically on number 1 firing of the injector, adding 5% to that. And we'll find that the injector pulse width it would increase based on wherever we're operating it in the table. It would be then adding 5% just to cylinder 1. All the rest of the cylinders would then run this particular injector pulse width it's calculating. So it's a pretty simple concept. If I go here and I type in -5, that would be taking 5% out. So we have the ability to go and add or subtract with it.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.